gone through this. Have you ever seen? Okay, no, I'm not sharing the screen. I'm just speaking. Don't worry. So I'm saying that you have read about RLC network, ALNR, LR network, and all these things you have gone through, right? Okay, you have gone through those LRC, RC, all these networks you have gone through, right? Everyone has studied that.
Yes, sir. I study.
You have studied, okay. So, can you please tell me, I mean, what is the minimum amount of information that you require to, to tell me what would be the waveform of the current of through an inductor?
Through inductor current, you are asking, sir?
Yes,
Waveform.
I'm asking that, I mean, if I give you an R and L and maybe a C, maybe a series RLC circuit, if I give you, what is
Okay, sir.
the minimum amount of information that you need to tell about or to predict the response of the system at any given point in time? What?
Two,
Sarvesh, what are you saying? Can you please repeat?
sir. Two informations will be needed.
And why do you say that?
Sir, history of inductor will be given by current flowing through inductor,
Very good.
and history of capacitor can be retrieved from its voltage.
Absolutely, absolutely. Very good, very good. Yes. So that is what state is. So as Sarvesh has just said, so depending on what the system is, you always need minimum number of information about minimum number of information that you require. I mean, the minimum amount of information that a person requires to predict the response of the system at certain period of time where t is greater than 0, of course, to predict the response is called state. So that actually means is what minimum information I have to give to you so that you can tell what the waveform would be after certain time. Okay, so that is the basic concept of state space. Those who haven't studied state space, they cannot attempt some, I think. But those who have, I would request them to try and attempt the sum that I will be showing you on screen. Let us let's see. Okay, just give me a minute. Have I started recording? Okay, recording is started. Somebody wants to come in. Okay, let me share my screen then. Okay. Okay, you can you can see my screen now, right? You can see, right?
Yes, sir.
Okay, great. Great. Okay then. Okay, so okay, good. So let me share my screen and state space. Okay. So we started with 2017. So this I think is the last sum of this control systems in this paper. So you try and somebody is trying to join. Let me just admit him. Okay. So I'm showing you one sum. What is the time? Let me just see. It is 7:03. It is okay. So let us start. Okay. So this is the equation. So this is the state space equation that has been given to you. So you see there are two states, x1 and x2, and you need to find out the transfer function ys by us. Okay, and the output relation is also given to you. Okay, okay. You can see the question. I think you can see the question, right? You can see it. Everyone can see the question. Everyone can see the question, right? Can somebody please?
Sir, good evening, sir.
Yes, sir. Good. Yes. Good evening. Yeah. Tell me.
Sir, starting is చెప్పండి సార్ ఇప్పుడే స్టార్ట్ అయ్యాను.
Please speak in English. I don't know. I mean, what you are saying, I do not know, man.
సార్ ఓకే
Some.
సార్
Can you speak in English, please?
ఓకే
Sir,
సార్.
he is telling that please start from the beginning, sir.
Start from the.
Beginning, sir.
బిగినింగ్ స్టార్టింగ్ బిగినింగ్ సార్.
You want me to teach state space?
ఎస్ సార్.
He want. I mean, so this
No,
session
no,
is
sir.
about.
Actually, no,
Yeah.
no, sir. What he's asking is he thinks that class has been started before.
Okay. What I said was I was just talking about what state is actually. Okay. So as of now, I'm switching off the screen so that you. I will give you some time to solve. So the thing is, yeah, I was talking about state. What state means. So that was that was the introductory thing that I just said. So what I'm saying is I will be showing you question. Okay, this is the question I'm showing you, and I will be giving you 3 or 5 minutes of time, and you have to solve it. And after 3 minutes, I would just ask you what answers you have got. Okay, so that is the way that we go ahead. So this is the question. Okay, the x1 and x2 are the states. This is state equation given to you, and you have to find the transfer function. Okay, your time starts now. It is 7:06. I will be I will be discussing again on 7:09. 3 minutes time. Just give me a minute. Somebody wants to join again. Okay.
Sir, I think it's option D, sir.
Option D. Okay. Who is that? Please tell me your name because I cannot see that screen over here.
Sir, my name is Ramtula, sir. Ramtula.
Ramtula. It is option D. You are saying. Okay.
Yes, sir.
Anyone else who can challenge him what he has said? Anybody wants to challenge?
Sir, I am saying option B, sir.
You are saying option B.
B.
B. Okay. And your name is
My name is Gangadhar.
Gangadhar. Gangadhar saying is option B, and Ram Tula is saying is option D. Let's see what is the correct option.
Sir, can solve it, sir, sum this one, this sum.
You have solved it.
No, sir. Yes.
Yeah.
Ask, explain, sir. I can explain, sir, this sum. Transfer function. Can explain, sir.
You can speak in your language. Maybe your friend will translate that for me. You can just speak what you are trying to say.
Yes, sir. Can explain, sir.
Sir, he want to explain by himself, sir.
సార్ నువ్వు మీ లాంగ్వేజ్ లో మాట్లాడమంటున్నారు.
Explain. ఈ సమ్ ఎక్స్ప్లెయిన్ చెయ్యాలి.
Sir, he is telling that you should explain the sum clearly.
I am not getting what he is saying.
Sir, he is asking you have to explain that sum.
I have to explain that sum. Okay. The question I have to explain. Okay. Okay.
Yes, sir.
Question
Got
and
it, sir.
answers. He is asking both question and answer.
Yes,
How-
sir.
Okay, we'll be discussing how to solve it, but first let the students try it out. Okay, what I am saying is this is so you know what transfer function is, right? You need to find output Laplace transform of output divided by Laplace transform of input, and the state equation is given to you. These are the state equations.
Sir, have you covered state space equations?
What do you mean by covered? Because we are not basically teaching we are just solving
Sir,
questions. These are previous year questions.
Okay, I thought you were teaching.
No, actually, in the first class, were you there? No.
No, sir.
Okay. So first class, I have told that we are not going for teaching over here. So what we are doing is, so you have to read on your own. What we'll be doing is, this is a practice session, kind of net practice. I will be giving you questions. I will be giving you 3 minutes of time, and you try to solve it. And then we will discuss. We will ask who has done it and who hasn't done it, and then we'll discuss why, if you have done some mistake, why you have done that mistake, and how to avoid that mistake, that we will be discussing. Full-fledged teaching we cannot do. I am a PhD student at Indian Institute of Science. We have our work. We cannot spend so much of our time to full-fledgedly teach all the entire syllabus. What we can do is we can help you out while practicing. That is the only thing that we can do.
Understood, sir.
Okay. Okay, so anybody else? So there are two people who has done it. They are saying it's option D. So Ramtula has done it, right? Ramtula, you are saying it is D, right?
Yes, sir. Yes, sir.
Yeah. Acha, tell me one thing. Just by looking at the these equations, can you just tell me whether it is a stable system or unstable system? Just by looking at the equation.
It is unstable system, sir.
And why do you say that?
Because some terms are negative polarity, sir.
Do not look at the
We can
options. Do not look at the options. Okay. Say I have given you only this thing. So many people. I mean, okay. So see, you just imagine that you only have this information with you. From only this information, can you tell me whether the system is stable or unstable? You only have
No,
this
sir, I
information.
don't know, sir.
Okay. Somebody else can try.
I think it is stable, sir.
Sir, I don't know, sir. I don't know, sir.
Okay. Anubhav.
Can explain, sir. This sum only.
Yes, I am explaining. Wait a minute. Yeah.
Okay.
Anubhav is there? Yeah. Can you try and say why, whether the system is stable or unstable from these state space equations?
आइगन वैल्यू निकाल के उसके पोल पता
Sir,
चल
question explain, sir.
अगर
In this
y हाफ
question.
में एचपी में लाई करेगा तो अनस्टेबल हो जाएगा
हाँ तो मैं ये बोल हाँ just by looking at the equations, can you tell whether it is a stable system or unstable system? Just by looking at the equation, no pen and paper, just by looking at it, can you say it?
Yes, sir, we can see it.
अभी मैंने
Yeah, how can you how are you saying it? Just tell me, how are you doing it? That's what I'm asking.
Because some terms in matrix present the roots present in the equation.
Can you please repeat?
So some terms present in the matrix represent the roots present in the
Which term?
Voice not clear. Voice not clear. So I can speak out.
I'm not sure about the terms, but some terms present the roots.
Some terms
Sir,
in this
you please
matrix.
explain, sir.
Yeah, please. I will be explaining. Just be patient. We will be going along. Don't worry too much.
How to identify with stable or unstable?
Yeah. So that is what I'm asking. So the thing is, so you know what characteristic equation is?
Yes, sir.
So you have gone through engineering mathematics,
sir.
right?
Yes, sir.
So how do you find characteristic equation in in the matrix theory? How do you do that?
Delta of Si minus A equal to 0, sir.
Absolutely. So do you remember what is the sum of the what does the sum of the diagonals say?
So it should be 0.
What is the sum of the diagonals? This diagonal I'm talking about. This sum 1 plus 0.
1.
Yeah, I mean what
Sir,
is
it's the sum of eigenvalues.
Absolutely. So what are these eigenvalues? Eigenvalues are nothing but poles.
Yes, sir.
Okay. So and what is the product of those eigenvalues?
0, sir.
डिटर्मिनेंट ऑफ द मैट्रिक्स
Absolutely. Determinant of the matrix. Okay. So what is the determinant of the matrix over here?
0.
How can the determinant be 0?
No, sir, it's minus 4, sir.
Right. So if the determinant is minus 4, so that means one of the eigenvalue must be negative and other one must be positive, right? Both is not negative. Right. Just a minute.
Yes, sir.
Okay. You're getting my point, right? So if the determinant is negative, that would mean that one eigenvalue must be positive, the other value must be negative, right?
Yes, sir.
So one pole is negative, other pole is positive. You agree with me?
Yes, sir.
Yes, sir. Absolutely.
Yes. So from that, in that way, if you think, then you can easily say that the system is unstable. Okay. Okay. Now let's get to this question. Okay.
Yes, sir.
So how do you find the transfer function? So the these are the state equation, and what we know is that in case of state space equation, the equations are written in form of x dot equal to ax plus bu. This x is the state matrix. Just a minute. Okay. Okay, this x and x dot, you see, this is x1 dot, x2 dot, and this x is x1 and x2. Okay, and this is the input. So so the equations are in this form. So the A matrix over here is this matrix. The B matrix over here is this matrix. And the C matrix over here is this matrix. Okay. So now we have to find this state transition matrix. So what is a state transition matrix? So this matrix gives you information about how the state of the system is evolving with time. That is why it is
Can
called
explain,
as
sir?
what?
Not understand, sir. Stay. Not understand, sir. Can speak. Explain, sir.
I can speak only English, man. I do not know any other language, so it is difficult for me to speak any other language. So, anyways,
Sir.
so if it is difficult for you to understand in English, then it is difficult for me to convey. Anyways, just listen to it then, because it is difficult for me to speak in any other language. Okay. So I was saying that what state transition matrix is. The state transition matrix give you information about how the state is evolving with time. Okay. So that is, so Laplace transform of the state transition matrix is given by Si minus A inverse. So if you do this operation, you are going to get this thing, 1 by delta S minus 1, 2 and 2. And this delta is a determinant of this matrix, which is S into S minus 1 minus of 4. That is what I have written over here. Can you please mute yourself, because
Okay, sir.
okay. Okay. So this is how you find the state transition matrix. So after you have found the state transition matrix, the transfer function can be given by C into phi S into B. The C matrix I have already shown you. That this is the C matrix. Having found the C matrix, you can do this operation and you can find the answer is D. So Ramatula has found the correct answer. It was D. It is okay. So is it clear to everyone, or does anyone need some extra clarity or something?
The delta equation explains, sir.
Please repeat how it is
Yes,
stable,
yes.
how to know knowing it is stable.
Yes. Can you please
Could
repeat?
you please repeat
Okay.
that part, like how to
Okay.
know that?
Yeah. I'm telling you. See, so for stability, for a system to be stable, where should the poles lie? The poles should lie in the left-hand side of the S-plane, right?
Yes, sir.
So what does that
Yeah.
mean? That means the poles should be negative, right?
Okay.
Yes, sir.
Are you getting me, Chaitanya?
Yes, sir. Yes.
So if the poles are negative and you multiply that two negative numbers, what would you get? What are you expecting to get?
A positive value.
A positive value, right? Okay. So look at this. Look at this matrix. So the product of the two poles would be the determinant of this matrix. The determinant is negative, and the summation is positive, right? The sum of the two poles, I am seeing it is positive, whereas the determinant is negative. That is the product of the two numbers, I am getting negative. Sum of two numbers, I am getting positive. From here, can't we say that one of the pole must be positive?
Yeah.
Yeah, from that perspective, I was expecting that you people will answer the question. Okay, so that was my way of thinking.
Got it.
So that might be complex conjugate poles now, sir.
Even if it is complex conjugate, so A minus B into A plus B, what is the product of it? A square plus B square, right?
Yes, sir. Yes, sir.
So what will you get?
I agree with that, sir. But if we get minus a plus or minus IB, sir, in that case it is stable, sir. Minus a plus or minus IB.
Minus a plus or
Plus or
minus
minus IB.
IB. Yeah, that case you are getting positive only, right?
That means system is stable now, sir.
Yeah, so here I am getting negative, right? What is the determinant over here?
Determinant here we get minus 4, sir.
Minus 4, right? So in that case, you are always getting positive, right? In the complex conjugate case. Getting my point, or
Yes, sir.
okay. Okay, then should we move to the next question?
Sir, I
Sir,
have a
sir.
small doubt, sir.
Yes, yes,
Sir,
yes,
I have a small doubt, sir.
yes. Please, please.
Sir, if depth of the matrix equal to 0, then what about the stability, sir?
If the
If data equal to 0, what about the stability, sir? How can we decide?
if the determinant of the matrix is 0, that is what you
Yes,
are
sir.
saying, right? If the determinant of the
Yes, sir.
matrix is 0, that means there must be one pole at the origin, right? But we do not know how many poles
Yes,
are
sir.
there.
Yes, sir.
But we do not know how many poles are there. If there are 2 poles, system will be unstable. So we cannot comment.
Yes, sir. Then we can't decide by seeing just matrix, sir.
No, you cannot
Can-
decide. But in this question, you can. I was saying in context with this
Yes,
question,
sir.
not
Yes,
with
sir.
any
Yes,
other
sir.
question.
Got it.
It is not a
Okay,
generalized
sir.
thing.
Okay, got it.
Yeah. Okay.
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 Sir, one question, sir.
Yeah. Anyone else? Any question or something?
क्वेश्चन ये सर कि अगर कोई मेरा स्टेडी स्टेट जो हम लोग स्टेडी स्टेट एयर निकालते हैं अगर वो नेगेटिव आता है तो क्या वो उसका मतलब वो मेरा अनबाउंडेड है सर कि जीरो है sir?
नहीं, स्टेडी स्टेट एरर का डेफिनेशन क्या है?
स्टेडी स्टेट ये सर कि कोई भी टाइम ये लिमिट ऑफ t टेंड्स टू इंफिनिटी जो भी मेरा फंक्शन हो वो
Say
मतलब फाइनल
suppose,
वैल्यू
what I have given a unit step to some system. So what I'm expecting is slowly it will go up, and at t equal to infinity, the response would become stable at at 1, at the value 1, right? That is what I'm expecting. But when you are saying steady state error is negative, that means it's less than 1. It is 1. If it is 1%, then it is 0.9 or something like that. Are you getting my point?
यस सर
अगर 1%, अगर बोल रहे हो कि if you are saying that steady state error is negative, that means whatever is your the expected steady state value, that is below that is 0.9. If it is above it, then it is called plus minus. That is why what we say is plus minus 2% or plus minus 1%. That is what we do.
मीन्स एरर कैन बी कम इन नेगेटिव सर बट व्हाट डज मीन मीनिंग इसका क्या होगा सर एरर नेगेटिव आता है तो
एरर यहाँ मतलब एरर नेगेटिव आ रहा है, इसका मतलब ये है कि तुम्हारा जो एक्सपेक्टेड स्टेडी स्टेट वैल्यू है उससे तुम्हारा रिस्पॉन्स जो है कम है. मतलब सपोज तुम एक्सपेक्ट कर रहे हो t इक्वल टू इन्फिनिटी में 1 होना चाहिए, मगर तुम्हारा सिस्टम का आउटपुट हो रहा है 0.9. ठीक है, तो ये माइनस 10% एरर हो गया तुम्हारा.
Sir, can solve it, sir, this sum?
हाँ, यस, प्लीज रिपीट.
Can solve it sum, this only sum. 33 question number.
Yes.
Please solve it, sir. I will note it.
The solution I just showed, right?
Can please show?
Excuse me, sir.
Sir, excuse me, sir. Please show.
I mean, it is very difficult for me to communicate with. What is your name? Pothala. What is your name, man?
My name is Gangadhar.
Gangadhar. Okay, it is becoming very difficult for me to communicate with you because you are having difficulty in understanding English. Then it becomes very difficult for me. I know only Hindi and English. I do not know any other language, man.
Sir, English, sir. I speak in English only, sir.
So what I have explained the sum. You are now saying to I do not know what you are saying. That means you haven't understood anything.
Sir, he's asking you to solve it.
Sir.
So isn't this the solution?
Yes, sir.
Then what
फिर उसको
solution is?
solution note करना है.
Question in this question.
Yes.
Yes.
This is the solution, Gangadhar. Actually, the solution has been shown in this slide actually.
Bro, you can take just a screenshot, bro.
Screenshot. Okay.
But these videos would be uploaded in NPTEL portal. You need not take screenshot also. I mean, these videos will be there in NPTEL portal itself. You need not worry.
Okay, sir.
Sir, excuse me, sir.
Yes, sir.
Okay, super, sir. Then go to next question, sir.
Sir, in the next slide.
Sir,
Wait a second, sir. Wait a second.
सर
Yes, yes.
सर एरर नेगेटिव आया तो मीन्स वो ऑप्शन में तो नेगेटिव का ऑप्शन है नहीं, जीरो का ऑप्शन है, तो जीरो का ऑप्शन को टिक करते हुए आगे बढ़ना है सर.
कहाँ पे हमको यहाँ पे स्टडी सेंटर कहाँ दिख नहीं रहा है हमको कहीं पे. स्टडी सेंटर कहाँ दिख गया तुमको?
जो एक मेरा क्वेश्चन था सर, जो क्वेश्चन प्रैक्टिस कर रहे थे उस समय मुझे सॉल्व करते समय मुझे स्टेडी स्टेट एरर का वैल्यू नेगेटिव है, मतलब उसका
नहीं,
मैंने
स्टेडी स्टेट एरर अगर जीरो हो रहा है मतलब जीरो हो रहा है, उसका मतलब नेगेटिव नहीं हो रहा है. ठीक है, तो तुम नेगेटिव कैसे बोल सकते हो? से सपोज
कैलकुलेशन करने के बाद नेगेटिव आया सर एरर.
कुछ गलती कर रहे हो फिर. ठीक है, से सपोज तुम्हारे पास पीआई कंट्रोलर है. ठीक है,
उसको हम सिमरिक में भी देखे सर, मैथ्स में भी सर किए थे तो वो देखे तो आउटपुट में जीरो आ रहा था सर, मतलब
so
स्टेडी स्टेट.
Abhishek, I would request you to send me the question itself, because I mean, without seeing the question I cannot say anything. It is very difficult for
Okay
me to
sir,
say.
I mail you sir.
Yeah, you just send a mail to me sending the question, because or else it becomes difficult.
Okay, sir.
Okay.
Sir, in the 33rd question.
One more question, sir.
Sir, in the question number 33.
Yes.
Sir, here you have written y is equal to c into u. Sir, but u is the x matrix. So can you go back
Yeah.
one page?
Yes.
Yes, sir.
Yes.
So here you have written y is equal to cu.
This CX
But-
it would be. This is a mistake. Please ignore it. This CX.
Okay.
Sir, what does it mean geo frequency gains?
I will come to it. Don't worry. I will come to it.
Okay sir.
State space equation of what, sir? Can explain, sir? State space.
You can please read the textbook for that. You can find it in Ogata or any other book, or Nagraj Gopal. You can just take and you can study it on your own. Then you can come up here and solve questions. It is not possible for me to teach you the entire chapter over here. It is impossible for me.
Okay, sir.
We are here only to help you solve sums. We cannot teach you. It is not possible for us. I mean, it would take a long time for me to prepare video lectures for you people.
Okay, sir.
Okay. So should we move to the next question, or should we wait?
Yes. Yes.
Any-
Next.
Next question, sir.
Yes, sir. Go to next.
Okay. So I'm starting with simple questions. This is another question which was given in GATE. Please take S as F itself. Do not put S is equal to J omega. Okay. So this is the question. A Bode plot has been given to you. Okay. A Bode plot has been given to you, a Bode magnitude plot. And you are asked to find the transfer function of whose Bode plot is given. So this is the question. Okay. Somebody is trying to. So this is the question. I will be giving you another 3 minutes time to solve it. It is a very simple question. Try and solve it within 3 minutes, 3 or 2 minutes. It is 7:31 now. I will be again asking 7:33.
ऑप्शन दिखा दे.
Is the options visible to you?
Yes, sir.
Yes.
D, sir.
Okay. D. Who else? Just a minute.
D ही होगा सर.
Okay, D. Okay. Anybody else? Two people have said it is D.
Yes, sir, it's T, sir.
Okay. Okay. One more minute left. Let's see who else can say. Okay. Time is up. Leave it. Who else have not done it? So people who are saying D, you can just come up and say why are you saying it's D?
एक्सप्लेन करना है.
करो explain. मान हो तो. Yes.
सर एक बार स्लोप -20 हो जा रहा है, मतलब
Right. How are you
increasing है.
saying -20?
-20 तो नहीं कह सकते, मतलब लेकिन 10 पे स्लोप निगेटिव जा रहा है तो एक पोल वहां पर होगा.
Correct.
और फिर 1K पे फिर पॉजिटिव हो रहा है, इसका मतलब एक जीरो होगा.
Correct. Correct. Absolutely.
और फिर गेन पता करने के लिए मतलब 20 log g करके इक्वल टू 20 कर देंगे, क्योंकि इनिशियली जो है 20 के इक्वल है गेन हमारा.
Okay.
तो उस तीनों इंफॉर्मेशन से ट्रांसफर
मगर तुम बोल रहे हो कि S10 पे एक पोल होना चाहिए, है ना? यही बोल रहे हो तुम?
यस सर.
मगर कितना पोल होगा कैसे पता चलेगा? यहाँ पे 2 पोल भी हो सकता है.
बाय द स्लोप.
स्लोप से पता चलेगा ना, तो स्लोप कैसे निकालोगे यही हम पूछ रहे हैं. हाउ डू फाइंड द स्लोप?
Sir, we are not understanding what you are
Okay,
explaining.
what please speak. I mean, okay,
change in change in magnitude in y axis by change in magnitude in x axis.
Okay, so what is it? Tell me what is the value of this slope? Tell me. Can you tell me?
Yes sir. 40.
So it is moving from 20 to 0. From when the frequency changes from 10 to 100, right?
Yes sir.
10 to 100 is 1 decade. When the frequency changes by 10 times, that means it is 1 decade. Okay, so that's why we say 20 dB per decade. So the slope has fallen by 20 dB in 1 decade. You understand what I'm saying?
Yes sir.
Decade, when I'm saying the term that we say 20 dB per decade means the frequency has increased by 10 times. Okay, so
sir,
tell me. Yes,
we can go by writing 20 minus 0 upon log of
correct. Absolutely. Log of 100 minus log of 10. Yes, minus of entire thing. Correct. Absolutely. So somebody was asking me about DC gain. Okay, so once you have the transfer function like this, you put s equal to 0 because s contains the frequency term. If you put s equal to 0, that will give you the DC gain. So if you put s equal to 0, what I am going to get is 100k. That is what I have written, 100k. Okay, now this 100k is equal to the gain at this frequency, that is at very low frequency, that is 0 frequency. So the DC gains means the gain of the system when the excitation frequency is very low. That is what we call the DC gain. So if put s equal to 0, we get 100k as the DC gain. Okay, now from the card what do you get? That is 20 dB. Okay, so it is 20 dB. So 100k, so 20 dB means 20 log 10 equal to 20. So in magnitude it will be 10. So 100k must be equal to 10. So k must be equal to 1 by 10. From there you substitute k from this and we get the transfer function as this. So the correct option is D. So people who was asking about DC gain, have you understood what DC gain is?
Geo frequency gains. I asked geo frequency gains.
Yes, that is only DC gain. Zero frequency gain is DC gain. DC means there is no frequency component present on it. That is DC. Yes.
Means geo frequency gain is same as DC gain, sir.
Yes, absolutely. Yes,
so we can find k by writing 20 is equal to 20 log 1 by gain.
Yeah, you can do that. You can do that. Of course, you can do that.
Okay, sir.
Is the solution clear to everybody, or do I need to repeat?
clear, sir.
Clear.
Okay. So now let me go for the next question. This question, let me see. Okay, this would be a bit of a, let's see how many people can answer this. Okay, so the impulse response of a system is given to you. That is this square pulse system, square pulse response, and there are two such blocks whose impulse response is same as this, and you are asked to find out the impulse response of the cascaded block. I will be giving you 3 minutes again, and then, huh? Who is saying the answer? I'm not.
Sir, D option.
D. Okay. Anybody else?
D.
D. Okay. D is the option. Okay. How are people saying that it is D? Please explain. Whoever is saying D. Anubhav, you are saying
Yes,
D,
sir.
right? Yeah. Tell me
Yes,
why.
sir.
Why are you saying D?
Sir, so we convolve the two functions,
Hmm.
the two unit step functions. So the slope
Yes.
will become 1 into 1, a product of 1 into 1, 1.
Correct.
So,
Hmm.
so for 0 to 1, it will rise to 1. So the
Okay.
maximum value we got is 1.
Okay. So,
On y axis, 1 into 1 is equal to 1.
what would be the impulse response look like?
Unit,
Yes.
unit step, unit step.
No. The convolution of this unit step and another unit step.
Yeah,
What would
yeah, it would look like a rectangular, triangular function. Sorry, sir, triangular function.
triangular function of
For 0 to 2, and
from
peak occurs at 1.
correct, correct,
Yes,
absolutely,
sir.
absolutely, very good. Yes. Okay. Let me ask somebody else because you are answering. Somebody else. Let me ask. There was someone who was just not very confident the other day. Who was that? I forgot her name. Nav Kirti was there, right? I forgot. Has she come over here today? Let me just see. Yeah, she is over there. Yeah, Nav Kirti. So can you tell me? Have you understood what I mean? What Anubhava just said?
Okay.
Have you understood? Hello.
No, sir.
Yeah, Srinivas. I'm not asking you. I'm asking Nav Kirti. Let me hear her response. You can just type in if you're not audible, Nav Kirti.
Sir, am I audible now?
Abhi, you are now audible. You are audible now. Have you understood what Anubhav just said? Maybe you can just type in because I cannot hear you. Okay, then I'm what I'm doing is I'm giving a step by step way how to do this graphical convolution, which is a generalized way, okay, so that everyone gets how to do it. Okay, so so what do you know when I'm saying that there are two blocks like this, and what would be the impulse response has been asked by us. So it is the convolution of these two impulse responses, right? So what we need to do, so the impulse response has been given to you in the form of a graph, not in mathematical form. So you need to know how to do graphical convolution. So I would first present a very step by step way of doing a graphical graphical convolution. The first, so you see the so you I would ask you to write down this expression, okay? So impulse response is equal to convolution of gt and gt, which is defined as 0 to t g tau gt minus tau d tau, okay? You note down this expression. This is very important because then you would understand what I am doing in the next steps, okay? So now, so if we convolute two such signals, the first step is to find the length of the impulse response. Okay, the length of the impulse response ht. I have represented impulse response as ht. Okay. So the length would be the sum of the length of these two signals. That is, the length of this signal is 1. The length of this signal is also 1. So the length of ht would be 2. 1 plus 1, 2. So what about the starting point of ht? That would be the sum of the starting point of these two signals. That is 0. What is the ending point of ht? That is the sum of the end point of these two signals. That is 1 plus 1, that is 2. So from the first step, we can say that ht starts from 0 and ends at 2. That is what we can say. Okay. Now from the expression, so what have you seen in the expression? The expression says g tau, g t minus tau. So g, the variable over here, is tau. So what we do in the next step is we change the variable from t to tau. Okay, that is what we do in the next step. So you see in the curve, I have changed the variable t to tau, and these are the curves for g tau. Okay. Now the next step. The next step is, you see, what are the two expressions we have? G tau and g t minus tau. So I need this thing. I need g t minus tau. I have already got g tau. What I need is g t minus tau. How to find g t minus tau? First, what we do is we find g minus tau. G minus tau would be folding of one of the signals. So you have folded this signal along y-axis. So that is g of minus tau. This is the curve like this. Now to find gt minus tau, what we do is we shift this signal by a term t. Okay, I shift this signal by a term t. Now this t is varying from plus infinity to minus infinity. So this block would be sweeping around this axis. It will be sweeping around this axis as we vary t from minus infinity to plus infinity. Just a minute, somebody wants to get in, I think. Okay. Now what we need to do is we need to find the overlapping area between these two signals as we sweep this. So I would request everyone to imagine these two blocks as the railway car, railway bogie, you can say. So imagine that these two are railway bogies, and this blue block is stationary, and we are sweeping this red block. That is, we are sweeping t from minus infinity, that is somewhere over here, to plus infinity, that is somewhere over here. We are sweeping this red block. This is stationary. So when would we find non-zero overlapping area? When will we find non-zero overlapping area? Anybody from the audience?
Sir, small doubt, sir.
Yes.
Sir, step 2 can explain, sir.
Step 2. Okay. Step 2, I have changed the variable from t to tau.
Yes, sir, doubt, sir.
What doubt?
Step 2.
Yeah, I have just changed the variable t to tau. What is the doubt in it? I have just changed the variable t to tau.
Yes. Yes, sir.
I am not getting you, man.
Sir, step 2 is a small doubt, sir.
What is the doubt? You have to tell me what is your doubt.
Change the variables from t arrow r in this sir.
I have changed the variable from t to tau. I have replaced t with tau. You have seen in the previous curve it was t. I have put tau over there instead of t.
Yes, sir.
Then what is the doubt in it?
Yes, sir.
What is your doubt? I am not getting what your doubt is.
Sir, అది ఎలాగొచ్చింది సార్ టీ ఆరో ఆర్
Can somebody please translate it for you?
టీని సౌత్ రిప్రజెంట్ చేస్తున్నా అంటున్నారు సార్ అక్కడ.
అదే అదే కరెక్ట్.
What is he saying? Anybody can please translate that? I am not getting what he is saying.
Sir, he is thinking that how is
He's asking about can you convert from T to T?
Why have I done it? Is he asking why have I done it?
Done, sir.
Yes, sir.
Sir, he's asking that it is R instead of tau.
This is tau. This is not r. This is tau.
Tau.
This is tau. This is not r.
S.
What is your doubt, man? You, if you keep on interrupting like this, it becomes very difficult me to conduct the session, man.
S.
I'm not understanding what your doubt is. You are not clear with your doubt.
S. Sir, not understand your language.
So I cannot change my language. I can speak only English and Hindi. It is not possible for me to learn another language now.
Yes, sir. English or Hindi, sir. Okay, sir. Yeah, I speak in English only, sir.
So I'm speaking in English only. What other language I'm speaking in?
No, sir. I am also speaking English only.
బ్రో ఏంటి బ్రో ఇంకా
Carry on.
Sir, it is waste of time, sir.
That is what I'm saying. If he keeps on interrupting like this, my flow also breaks, right? I was just telling what I told. I for myself forgot. This is very irritating actually. Okay, anyways, what I was saying, yeah, I was saying that, okay, I was requesting you to imagine these two as two blocks, okay, two blocks, and imagine that this red block is moving, okay,
సార్
this, yes, hello, Vignesh, you have to say, you want to say something?
No, sir.
Okay, okay.
Vignesh.
Who is this?
Asuntanava. Tade Vignesh.
సార్ రిమూవ్ దట్ పర్సన్
Hello?
Yes, tell me, yes.
No, sir, I have no doubts, sir.
Okay.
No. Thank you, sir.
Okay. What was I saying? I was talking about the overlapping area. Okay. So what I was saying was I was requesting you people to imagine these two as two railway bogies, and I was saying that you have to sweep this railway bogie along this axis. You have to sweep it, and you have to find where are you getting that overlap of the areas. Okay. So can anybody tell me when would you get non-zero overlapping area?
So
Hello?
it's 0 to 1, sir.
Right. When t becomes 0, you will start getting non-zero overlapping area because these two trains is, imagine that this train is stationary and this train is coming towards it. So as t becomes greater than 0, it gets inside it, just like the way I am showing in this picture. See, so I have, as I'm sweeping this red block, we see that when t is between 0 to 1, we are getting non-zero overlapping area. So how to find it? So 0 to t, the value of g tau, that is 1, and the value of g t minus tau, that is also 1 into dt, which becomes equal to t. So ht is t from 0 to 1, which means the overlapping area is actually increasing as we move from 0 to 1. So when these two blocks are absolutely overlapping each other, the area would be maximum. So when t equal to 1 and t minus 1 equal to 0, that is t equal to 1, then we will have a complete overlap and the overlapping area will be maximum. As t becomes greater than 1, the overlapping area again starts falling because the train is now leaving. Right. So as t becomes greater than 1 and t greater than 1 and t minus 1 is less than 1, that is t is less than 2, then this area would be falling. So to find the expression for the time interval 1 to 2, we will integrate from t minus 1 to 1 the value of the two functions at that time dt. So that becomes minus of t. From here we can find that ht is equal to t from 0 to 1 and it is equal to minus t from 1 to 2, or else it is 0. So the correct option is D. But we need not go for all this lengthy procedure, for competitive exam. You you have to keep certain properties of convolution in mind. The first property that you have to keep in mind is if we convolute two rectangular pulses, what we get is two rectangular pulses of equal width. Then what we get is triangular pulse of twice the width. That is what we have got, right? So this is the width of each of this square signals was unity. The width of each of these square signal was unity. What you got was a triangular signal of width 2. Okay, so this is the thing that you have to keep in mind. This is one of the properties. The second property is the slope of this rising arm would be the product of the amplitudes of each of the convoluting functions, each of the functions that you are convoluting. So the slope would be product of the amplitude of this function and this function, that is 1 and 1. So it becomes 1. The slope has to be unity. So what you have got is a unity slope. So the slope would be rising from 0 to 1. Okay, and then again it will be falling. So to check whether what you have done is correct, you have to keep another property in mind, that is the area of the resultant convolution is equal to product of the area of individual signal that is being convoluted. So what is the area of this triangle? Half into base into height, that is equal to 1. And what is the product of the area of these two square pulses? That is also unity. So we can say now that we can verify that whatever we have done is correct. Is it okay, or do I need to? Is everything is it okay or?
Okay,
Yes, sir. It's fine, sir.
Okay.
Sir, sir,
Yes, sir.
sir, notes. Please send me notes, sir, in class. PDF.
Notes.
Yes.
This is a question practice session. We are not teaching you the entire syllabus, or we are not teaching you the chapters. This is a net practice session. Please try to understand it.
Sir, please send me, sir, notes.
How would I send you notes if there are no notes to send?
Carry
Sir,
on.
please go to the next question, sir.
Of, I mean, he's breaking my flow. That is the problem actually. If you
Hello,
keep
sir.
asking me this kind of questions, he's breaking my flow.
Hello, sir.
Yes, please tell me. Yes.
Good evening, sir. The convolution between the impulse and unit is
Yes,
unit
yes,
step
yes.
now, sir.
Yes,
But
yes, tell me.
the rising slope is 0.
The rising slope. Which rising slope? Rising slope will be unity, right? Why do you say it is 0?
So output is unit step now, sir. Slope is 0 now.
Yes. Yes, yes.
But the impulse amplitude and the unit amplitudes are not 0.
Not getting you. I'm saying that the slope of the rising arm of this. I'm saying that the slope of this signal, the slope of ht, that must be equal to the product of product of the amplitude of each of these signals. Each of these signals, the amplitude
Yes,
is
okay.
1. Here amplitude is also 1. So the slope of the rising arm would be 1 into 1, that is unity.
Okay, it is only applicable for only rising arms, means rectangular, which
For
has only
falling
slope.
arms it would be negative of that. So if it is, so if the question was like this, say, so it was given that this two are of, if these two width are not same, what would be the output? What do you think, what would be the output?
Trapezoidal.
Yes,
Trapezoidal.
that is
Trapezoidal.
right, absolutely.
Trapezoidal.
Absolutely. So the slope of the rising part of the trapezoid would be 1 into 1 if the amplitude was 1.
Yes, sir. The output is having the slope. So you are saying that amplitudes are multiplication of amplitudes. If
Yes.
not, the output is unit step. It doesn't have a slope.
Oh no, then you cannot apply. Then you cannot apply. This is a property which is
Yeah.
applicable
Okay.
for this.
Okay, sir. Okay, thank you, sir.
Okay,
Thank you.
okay. What else was the question I was about? How many questions have I discussed?
2, sir.
Okay. So this is the last question. I have time up to 8, so I have 3 minutes left. So you have to complete this question within 3 minutes. It is 7:57 now. I think it is, yeah, 7:54. Try to solve it. I have solved a similar question in the previous week. Try to solve it. Tell me what is the answer.
B.
B, sir.
Somebody is saying A. Who else?
B.
Somebody said D.
B,
Okay, then
Bombay.
yes.
B, Bombay, sir.
B, right? Okay, okay. Yes, the correct answer is B only. Right, correct. Yes. So I do not have much time. I just have 2 minutes time. I'm just showing you the solution very fast. So the previous week I have just given you how to do it. First, you list out all the gain. That is the forward path gain. That is G2, because the input we are concerned with is X2 over here. So the forward path gain is this X2 as I'm showing in the cursor. So this is the G2. That is the forward path gain. So forward path gain is G2. Now we have listed out the loops, the loop gain, that is G1, G2 into minus 1. So minus of G1, G2, and the loop 1, that is minus of G. Okay. So now first we have listed all this. Then we define a term delta, which is equal to 1 minus sum of individual loop gains, and then plus sum of, but this all terms will go to 0. We are left only with the first two terms, that is 1 minus sum of individual loop gains, that is 1 plus G1 into G2. And then the transfer function is given by G1 into delta 1. Delta 1 I have defined like part of delta which is not touching the forward path, that is G2. So we will end up getting this expression. So the correct option will be B. So whoever has got B is the, so he or she has got the correct answer. Okay. So I'll be asking a few questions. So I will be asking the, yeah, Navkirti only. So last class you are very worried. I'm just asking you, are you feeling confident, or what is your status now? Navkirti, you can just type in. Okay, that is good to hear. That is good to hear. That is good to hear.
Sir, where we can find this recorded session, sir? This record session will be uploaded in NPTEL, sir.
Yes, that they would be handling. I am not handling. We are just asked to take live sessions.
Okay.
So and we are asked to record these videos, and we are asked to send it to the concerned authority at IIT Madras. We'll be sending it,
Okay.
and they would be uploading it.
Okay, sir. In which portal, sir? This portal only?
There will be a NPTEL portal only. They will be uploading it.
Okay, sir. Thank you, sir.
Okay, so it's a request from people who do not understand English, or have difficulty speaking or understanding English. It is not possible for me to learn a new language. It is very difficult for me, because see, I myself is a student at Indian Institute of Science. It is not possible for me to learn a different language now and teach you. It is impossible for me. So if you make that kind of a request, what happens is the class gets interrupted, and my patience, we people lose patience, the flow of the teaching goes away. So this kind of request is something which I cannot, I cannot satisfy you by learning a new language and teaching you in that language. And it is completely, because we have already told this session are our practice session. This is not a session where I am going to sit and teach you the chapters. It's not possible for us. So I would request everyone to understand our situation also. We are also students. We are also studying over here. So I would request you to understand our condition also. So it's only possible for us to try and help out with sums. That is the only thing that we can help you out with. So that is the thing. So I would request anyone who is having problem with English, either you get a friend who can translate the entire thing for English, or get some other help, because I don't think I would be able to help you in any way. So because in the middle of the class, if you do that, then everything goes away. My whatever plan I make, whatever the time planning, everything gets destroyed. It's just a request to you guys. Okay, that would be the end of our session. It's already 8 o'clock. Okay.
Yeah, okay, sir. Okay, sir. Thank
Sir,
you, sir.
thank you, sir.
But
Thank you so
if
much, sir.
any students
Thank
ask
you.
in any other language, also you can answer in English, sir. No need to answer the same language what the students knows.
Okay, man. Yeah.
Yeah, okay. Yeah, okay. Thank you.
Okay, thank you.
Yeah, thank you.